intelligence being ventured into pharma research, these are all have become mandatory or essential. So one who is taking up the pharma research in whatever field it may be, I mean to say it can be a synthesis or extraction or pharmacological study or analytical study, whatever it may be, one has to have a understanding with all these terminologies. So, of course, it's not possible for us to have a fullest understanding in 1 hour session. So, another 1 hour session, I will be taking you through all these terminologies, and maybe you will be familiar with few topics also. So when we talk about statistics, the most important thing that pops up into our mind is population and sample. So nobody can forget about this. So population. So what is a population? It's a collection of outcomes and responses for which you are carrying out a particular study. So it is not possible for us, whatever the study may be, it is not possible for us to conduct a study in the entire population. So we go for a sample, and a sample is the most prominent subset of population, and the selection of sample size is very vital and important thing in any statistical research. So there are two different branches of statistics which are very important, and we are going to learn everything associated with this. So the first one being descriptive statistics. So descriptive statistics, it involves organizing, summarizing, and displaying the data. So statistics is all about playing with data, right? So I don't want to give definition of statistics, advantages, disadvantages, all this everybody know. In one word, I will say it's essential for your research. That's all. Whether you understand the definition or not, it is essential. So how you play with your data, that is the very important thing in statistical point of view. So descriptive statistics, and another one is the inferential statistics. So they have equal importance. Whatever the data may be, you can have both kind of uh, statistical tools that can be applied for your data set. You can have results that will show for descriptive statistics that will describe about your entire data. You can also have results that are associated with inferential statistics, and inferential statistics are very important for making your conclusion and interpretation of your results. So I am talking about data. So your status, if you don't have data, you don't have to worry about statistics at all. Statistics is everything associated with data. Right. So data, what do you mean by data? Again, you have different types of data, qualitative and quantitative. So your research may fall under any of this category. It is not necessary it should have only this kind or that kind of data. You have a statistical tool for any kind of data. So first and foremost, there should be an understanding of what kind of data you have in your hand. So whether it is a qualitative or categorical data you have, or you have quantitative or numerical data, this is the first and foremost understanding you should have with your data. Again, in qualitative, you have different types like nominal as well as ordinal, and quantitative, you have interval as well as ratio. So still you're confused. I have some examples for you. So this first one is a nominal kind of data. So nominal kind of data categorize the data set into different gender, male and female, right? Then we have ordinal kind of data that again falls under qualitative, where we can categorize them, we can arrange in a particular order. For example, if you are measuring the length of air can be measured. Length of air can be categorized, ordered, very small, medium, then large, and then very lengthy. So you can order them. That is said to be qualitative, but still ordinal data. Whereas if you are measuring the color of eye, if you are something research you're doing on the color of the eye, color of the eye is only of two category, brown and black. So there it falls under nominal kind of data. So understanding what kind of data you have is very important, because your selection of the statistical tool completely depends on the kind of data what you have in hand. So next category is, both the categories are quantitative. In quantitative, we have interval measures and then we have ratio measures. So for interval measure, the best example given is IQ, whereas for ratio, it is the income, right? So these are some of the few examples, but not restricted to this. You can have plenty other examples too. So let us quickly jump into the descriptive statistics. So what is descriptive statistics? So I have categorized the entire descriptive statistics into 4 heads. So the first one being measures of central tendency. Nobody can escape from this. You could have even heard of all these terminologies in your higher education itself. Nowadays, I find these things in school books. So we could have heard all this. You would have already heard about this mean, median, and mode. So that is one category of describing the data. What is my center value? So the mean, median, and mode put together is said to be the measures of central tendency, where you say that this is my set of data for this particular set. This is the mean, this is the center value, and mode is the repeated value, right? And of course, each and everything has its own significance, right? We cannot go in detail of it. I'll just give an overview of each and everything. The next important step in case of descriptive statistics is graphical method of representation. The moment we see the graph, we can judge how the data is distributed, right? So you are bothered about the center, how the central tendency is, and how the dispersion is, measures of dispersion, the range, standard deviation, variance, and then skewness. And this measures of central tendency and measures of dispersion, you can calculate and give it in terms of numbers, or you can also graphically represent it. These three are actually interconnected. I should say these three are actually interconnected. You can bring all these three category in one go. So when in one single histogram or in one single graph, you can make a representation of all the measures of central tendency, measures of dispersion, and whatever you would like to convey through the graph can also be conveyed by graphical methods. And our next category, next important category is measures of relationship, which is also very important because many times we want to study the relationship between the different variables that are taking place in our experiment. So that is given in two terminologies like chi-square test and the correlation studies. Right? So this is all about the descriptive statistics. So once you have a parameter and you have to decide, parameter again, I mean to say the data. So data, you have to decide whether it is in the form of metric or in the form of categorical. So if you have a metric kind of data, metric means you have a solid value, concrete value in your hand, like body weight, body height, blood pressure, age. Most of our scientific research involves metric. If you are doing some survey kind of analysis, there you will involve more of nominal and ordinal kind of data. Whereas all wet lab analysis, either it can be pharmaceutics synthesis or your pharmacognosy or analytical, that will involve metric kind of data. So if you have such kind of thing, so I have given here few graphical representation in order to catch your attention. So this you can see from the graph, you can easily make out how the data is being distributed. This is the histogram and this is the box Wister plot. So there is a possibility of representing your data in a graphical representation, and you can also have a description on what is the mean value, standard deviation, median, minimum, maximum percentile, and the skewness of all this graph. So shortly, we will be seeing how to calculate all this using our Excel, MS Excel, right? So this, if it is a categorical, and in categorical, definitely you need an understanding whether it falls under nominal or it falls under ordinal kind of data. So if it is a nominal kind of data, better it can represent the absolute and relative frequencies and then the modal value. And if it is an ordinal kind of data, you can represent median, first and third quartile, and all this kind of descriptive statistics can represent and can talk about your data. You need not have to talk. See, once when you see a girl, you like to describe how she is, how tall she is, fair, and then she has a long hair, beautiful eyes. So we describe, right? So this is a mode of describing the data set, what you have in your hand. And when it comes to a very large number of data set, it is very, very essential to describe your data set. Only then others will be interested to know, right? So statistics without formula, no chance, is it not? So if it is a statistics, you have to know the different formulae that are involved. So here I have given a different formula of mean, variance, standard deviation, skewness, median, range, all this. Don't be scared of all this. It's a very important to have at least to know whether you use it or not, at least to know the formula is very essential. Of course, when you use Excel spreadsheet, you won't require this memorizing all this formula. You have inbuilt formula, so you have to simply know how to use them. That's all. So what for the descriptive statistics is used? It is to provide the basic information about the different variables that you are using in a data set. And it also highlights the relationship between different variables that you take it for your study, right? So these are the two objectives of doing descriptive statistics. And statistics is not without the formula, and the formula you should know to have a better understanding. For example, here actually the formula of standard error is not given here, but I'll say you the standard error of mean is another important parameter in descriptive statistics, and it is calculated by using a formula called the standard deviation by root n, right? So or let us take the standard deviation. Standard deviation, if you look at the formula of standard deviation, so the standard deviation formula is square root of variance. So variance formula is given above, that is x minus x bar the whole square divided by n minus 1. What is n generally in any of the statistical thing? N is the number of observation, number of data set, what you take it for your study. So when it comes to n is in the numerator, denominator. So when you have some troubleshoot, you find that the variance is more, the standard deviation is more in your study. So what can you do? You cannot manipulate your data. Instead of manipulating the data, you can understand where you can modify experimentally. So in your experiment, you should do some modification, like you can increase the sample size. The sample size can be increased in such a way that you can reduce the variance or standard deviation to your expected level, right? So it is important to know the formula, but I won't say memorize the formula. Memorizing the formula is needed when it comes to exam point of view. We ask our students to do by using paper and pen and calculator with the formula, and I also teach them how to do it with Excel, right? So, but always for research, Excel is easiest tool. You can use that. Inbuilt formula are there. I will teach you that now, so that you can use that for your research. But understanding the formula is also important. That is why I've given here because talking statistics without formula, I'm not doing justice for that particular field. That's why I have introduced some of the formula, not all, only few formula I have introduced you. So this is again another example. That is, I told you initially, you can give a graphical representation which will talk about your data. So this one single graph, if you take, it's a box whisker plot. So it gives you the entire detail of the total data, whatever you have collected. So you can see which is the median, midpoint of your data. What is your maximum value? What is your minimum value? And there is one point that doesn't fall in your data set at all. That is said to be outlier. So understanding all this is very important in order to know what kind of data you have. Of course, if you require any modification, if you want this outlier to be overruled, you can do your experiment again and see. So this kind of graphical representation will support you, will help you for better understanding. So there is a lower quartile, which is 1/4 of the entire data set. Upper quartile is 3/4 of the entire data set, whereas median is the
mid value of the entire data set. So just by seeing the graph, you can understand. No need to describe each and every parameter, right? So this is the beauty of descriptive statistics. So here again, I have given different examples of other charts too. So this kind of distribution of data set is said to be normal distribution, parabolic and normal distribution. This is how we find most of our data in our pharma research. That is again a very interesting point. And again, it's an advantage for us to have such kind of data. And most of the statistical tools, whatever we are going to read, that will apply only when you have such kind of data in your hand. So you can see here a very nice parabolic curve, bell-shaped curve, which tells you about the distribution of the entire data set. You have a center value here, and it is symmetrical. It means what? You have equal number of data that is on the left side and equal number of data that is on the right side. That is the number of data that is having more than the mean value and less than the mean value or same. So whereas here in this graph, you can find out in this plot, you can know that it has a skewness. So this is what it shows. So once when you plot a graph, you can have an understanding how the data is distributed. And with the histogram, you can find out how the data is distributed, whether it is having multimodal or unimodal, bimodal. All these are some of the examples of descriptive statistics, right? Okay, so this is all about descriptive statistics. We will be doing descriptive statistics with Excel. After once I complete my entire PowerPoint presentation, we will be shifting to Excel spreadsheet and we will be doing some of the calculations of descriptive statistics. Next important parameter, next important thing is inferential statistics. Actually, descriptive statistics is like child's play. It's very, very easy, absolutely easy. Anybody can do. Inferential statistics is very important because based on the inferential statistics, you will draw conclusion of your result. Entire experiment, what for we do? So when you start with inferential statistics, you need a question. Why you are doing this particular study? You have a question to be answered by the end of your study, is it not? So that is the first step. And next is formulating the null and alternate hypothesis. Hypothesis is something like assumption. Hypothesis is nothing but assumption. So null hypothesis means we assume that there is no change in your study. Say, for example, you are synthesizing a new compound. Why you are synthesizing a new compound? You want your synthesized compound to be better than the existing one. That is your major aim. That is your first statement. Your statement of question to be answered is whether my new product is better than the existing one. That will be your question number one. Whereas the null hypothesis, what you will assume is my new synthesized product is similar to that of the existing one. That will be my null hypothesis. I will assume so, right? So before any research, you should set a null hypothesis or alternate hypothesis. Once you set the null hypothesis, it's automatically understood that alternate hypothesis. If somebody is coming and asking you, will you take idli or puri? So if you say, if your option is idli, it's understood that you don't go for puri, right? So likewise, once you take up the null hypothesis, it means that your alternate hypothesis is kept aside. You go with null hypothesis, right? So then the next important step is you have to fix up the level of significance. So these are the different terminologies which you should understand in inferential statistics. First step is null hypothesis. Second one is level of significance. We don't have much choice there. We have only two choice. One is 0.05 and another is 0.01. So you have to either take up left or right. By default, people opt for 0.05 level of significance, or it is also called as 95% confidence interval, right? So since the audience must be mixed group, some of you may be students, some of you may be faculty members. So some of you might have known all this. You would have come across all this terminology. Some of you may be new to this terminology. So anyway, but keep at least remember these points so that you can learn, you can equip yourself with all these terminologies later. So that is very important, level of significance. So null hypothesis and level of significance should be fixed first before you start your actual statistical analysis. Then statistical analysis will be carried out. So you have to calculate the p-value or the actual value. Then the decision on the null hypothesis will be done based on the critical value. These are the four important steps in your inferential statistic. I have few more slides, so same thing will be repeated so that you can be familiar with this terminologies. So why we need all that? And there are error. There are chances of making error. There are probabilities. Okay. So when you accept the null hypothesis when it is true, that is said to be the correct conclusion. When you reject the null hypothesis when it is false, that is also said to be the correct conclusion. So hypothesis is what? You are assuming something. Whether you are going to accept the hypothesis or reject the hypothesis, what it depends on? It depends on the calculation what you are going to do. Right? It all depends on the calculation what you are going to do. Whether I am going to accept the null hypothesis or reject the null hypothesis. So if it is true and you reject, that is said to be type 1 error. If it is false and you accept, that is said to be type 2 error. So in order to avoid making these errors, these are the steps that has to be followed. Again, the same thing is being repeated in order to familiarize the terminologies. First thing is you have to decide on the study design what you're going to do and the sample size. Next is the test for statistical significance, which is nothing but 0.05 or 0.01. And then you have to do the calculation. In calculation, we have to decide whether we are going to do paired t-test or t-test, chi-square test, f-test. That's what we will be discussing now, right? How to decide on which type of calculation I should do. But this procedure, these steps are common for whatever statistical tool you opt for under inferential statistics. First step is null hypothesis, then test for significance, level of significance, that is 0.05 and 0.01, then the calculation, then you have to compare the result with the critical value, that is table value. It is so called as critical value or table value. Depending on the critical value and table value, we have to decide whether to accept the null hypothesis or reject the null hypothesis. I'll tell you that how we can do that. As of now, you remember this 4 steps. For your review, fixing up of null hypothesis, test of significance or level of significance, calculation, critical value, then your comparison and making the decision, right? So again, there are different questions that has to be answered. So depending on the different questions, you will opt for what kind of inferential statistics you can do. I am not introducing you with different things and then definitions, advantages, disadvantages. That becomes more of theoretical. So I have just given the flow charts. I will leave this PowerPoint to the organizer. You can take it from them and you can go through it so that you can have a better understanding also, right? So the first question, what has to be answered through inferential statistics is, one second. So is there a difference between the groups or data sets that you have? See, when you have 2 data sets, for example, A and B, the nomenclature can be anything. It can be A and B or X and Y. We don't bother what nomenclature you give, data set 1 or 2. It doesn't matter. But how we are going to go with it? So if you have A and B, for A, you will have a descriptive statistics. For B, again, you will have a descriptive statistics, no doubt in it, right? But when we are going to compare them, when we are going to compare both of them, we will go with the inferential statistics. We will step forward for inferential statistics, right? Am I clear? So data set A, data set B, you have descriptive statistics for data set A, You have descriptive statistics for data set B. When you want to compare them, you will jump into the inferential statistics. And if you want to answer whether there is any difference between this group, two groups or data sets, again, you have to find out whether the data is of numerical type or categorical type. And in numerical type, it is again classified as parametric and non-parametric. This is again very, very important. The one way of categorizing statistics is descriptive and inferential. The other important way of categorizing statistics is parametric and non-parametric test. And of course, many of our research again falls into parametric category. That is, you will have the normal distribution of data as I showed you in your descriptive statistics. Normal distribution of data. What is normal distribution of data? If I have a symmetrical curve, right? If the distribution is ranging from 10 to 100, if the distribution is ranging from 10 to 1000, but if they are equally distributed, then that is said to be normal distributed. They are said to be parametric in nature. Whereas in non-parametric, you will have lot of variations in the distribution. You will have one value as 100, whereas another value as 1000, another value as 1. So there you cannot have a justification. Even mean calculation will be difficult in case of non-parametric data. So in such cases, again, so in parametric, if you have only two groups to be compared, we prefer doing students t-test and f-test. If you have more than two groups, we prefer doing ANOVA. And in ANOVA, we have one way, two way, and all those, right? So if you have non-parametric data set, we can have Mann-Whitney U-test and Kruskal-Wallis test. If it is only two groups, we can use Mann-Whitney U-test. If it is more than two groups, we can use Kruskal-Wallis test, which is equivalent to ANOVA. So again, if it is a categorical data, if you have to compare only two groups, you can use chi-square and f-test. If you have more than two groups, you can use chi-square alone. Okay. So this is another set of questions which you can answer by means of all the statistical tools. Is there any difference between the groups or data sets that are paired? Paired means crossover study. Say for example, see what is the difference between unpaired and paired research? Unpaired means they are totally independent. If I have a, say for example, I am measuring the BP of students of class A and class B, right? So that is my unpaired data. If I am measuring the BP of students before Viva and after Viva, okay, so same set of students in a class A, I am measuring the BP of students before Viva and before after Viva. Or if you are doing some interventional studies. So when you, most of the interventional studies, how you will do? You will take readings or you will do the research before intervention and you will do after intervention. And you have to compare whether there is any difference. So what do you say? Will there be any difference in BP before Viva and after Viva? Definitely is. Definitely yes. Whether nowadays, instead of measuring the BP of students, I think BP of faculty has to be measured before Viva and after Viva, right? So it's on the lighter sense, but still that is practically you can do it and see. So when you want to compare the BP measured for same set of students before and after, that becomes paired data. So that becomes your paired data. So that is most important. And in such category, parametric and non-parametric, again, you have all these options. Almost it will be similar with few modifications in non-parametric type, right? So if it is parametric, so parametric statistical studies are very popular in our pharma research. And you can even go through many of the articles. After this session, please go through some of your literature, whatever you have collected. You will find all this standard deviation, standard error of mean, then paired t-test, t-test, f-test, chi-square test, ANOVA, all this. So nowadays, you can't find any paper without ANOVA calculation, right? So next question, what you can answer through this inferential statistics is you can find out whether there is any relationship, there is any association between the variables what you have taken for your study. So if you are measuring height of particular people and weight of the people, or some kind of other analysis, some kind of analysis you are measuring, some blood samples you are measuring. So is there any correlation between these two data, to these two variables? Then for that again you can have an answer with inferential statistics. So again we have categorized into parametric and non-parametric. In parametric we have a calculation called Pearson's correlation coefficient, r square, and in fact this is very commonly used in analytical procedures where we find whether there is any correlation between the absorbance measured at a particular lambda max. Or if it is a non-parametric data, you can find the same correlation using Spearman's rank correlation data. And these are all with the categorical data, right? So these are the different analytical tools which are available for our study. And here, based on the literature, I have given here what are the most frequently used statistical tools in our pharma research, of course. In health research, we need not even have to categorize as pharma research. We can even extend it to health related research. So Fisher's test, chi-square test, student's t-test, ANOVA, and here if you see, I have given the exact definition or exact description where it is being exactly applied, right? I'm not going to talk about all this because we have other important things that are coming up. Okay, so these are some of the other statistical tools which are commonly used. If you have a doubt, you can cross-check with literatures, whatever you have with you. Okay, Wilcoxon's rank sum test, Kruskal-Wallis test. So Pearson's correlation, Spearman's correlation, all that, right? Okay. So this is another algorithm which will be, so now being told about descriptive statistics and inferential statistics. Now, how to start with? So this is a pretty good algorithm for selecting your study depending on what you require, what you need actually. So I have given here, it's a clearly represented. So we are going to start here. Again, you will decide which way to proceed, either towards upward or towards downward, depending on the data what you have. If you have measurement kind of data, you can do a mean and a 95% confidence interval for all the replicates, whatever you do in your research. If you have frequencies, again, you can go with what kind of test you need to do in that. So here also I've given another step called what kind of test you want to do. Whether you want to check the relationship between the two tests, or you want to find out whether there is any significant difference between the two data sets. See, many a times we try to find whether there is any significant difference. So nowadays, I used to say even in statistics, even beauty has to be defined. You cannot say she is beautiful, she's more beautiful than her. Or you cannot say she is more taller than her. No, she's taller than her. No, you cannot say that. You have to be very specific. Taller means in how much, in what way. So you have to be very specific in your results, whatever you give. So always we need that differentiation between the data set. I cannot say, yes, my newly synthesized product is better than the existing one. In what way it is better? Is it significantly different? So unless and otherwise there is any significant difference, nobody will accept it. So if there is only 0.01 inch tall, that is not acceptable as taller, right? So there should be some parameter for each and everything. There should be some significant difference. So that is what we are seeking, and that is what we are trying to prove. So you are trying to prove that, yes, my newly synthesized product, my new extraction is better than the existing one. My new formulation is better than the existing one. So we always have this kind of testing for difference between the data set is what is frequently used in our studies. So again, there, if you have only two data sets, if you have normal data, I mean to say here is parametric. And if it is same individuals, that's what you will do paired t-test. So everything, whatever we have discussed in previous 3 questions, I have put you the different questions. I have uh, I have given you, I have made you to visualize the 3 different research questions. That is where your research will be. You will have these 3 research questions in your each and every research. So these 3 questions are concised into this algorithm. Please have with you this algorithm, and this is not framed by me. Of course, I have taken from other literatures. So you can have it with you and you can decide how to go with it. So here again, if you want to study the relationship between the 2 data set, you can go for checking the correlation, and it can be Pearson's correlation and it can be Spearman's correlation. So you might be wondering, there is one formula that is given in each and everything. Say, for example, let us go to the first box, very first box on the top of the screen. So it says Pearson's correlation coefficient, right? So equal to Correl, in bracket, it's given range 1 and range 2, right? So 0 is no correlation and 1 is perfect correlation. So this is CORREL is the formula which you use for calculating the correlation coefficient using Excel. Actually, this entire algorithm is to go with Excel. So that is why you can see in the midway, halfway through, you can see that Mann-Whitney U-test is not possible. It is not possible to do this particular test in Excel. Most of the parametric tests are possible. Non-parametric tests are not possible to do with Excel. That's why people nowadays shift to different other softwares. But it's not necessary. Excel is a very user-friendly. Excel is most reliable, and you know, another important thing, whenever you want to use any of the other software, for example, SPSS, SAS, R software, whatever it may be, your first step will be filling up data in Excel. So you have to fill all the data, whatever you collect, all the data should be first filled in your Excel spreadsheet. And then the entire data has to be exported into the actual software. So when it comes to academic research, see, when it comes to industry, okay, they can opt for costly softwares. They can buy. When it comes to academic research, when it comes to your PhD or whatever it may be, so academic research can be very well done with using MS Excel. It's a user-friendly tool, and you can do wonders with Excel itself, right? And so this is all about the descriptive statistics. I have taken the screenshot, but we are going to shortly do the same thing with our Excel also. I'll be opening the Excel and I'll be quickly taking you through Excel also. But this is the screenshot what I have shared so that you can go through, even in future, you can go through that. So again, we are moving back to our descriptive statistics. So here you can see I have taken 2 groups, group A and group B. So these are the data set. Of course, we have taken only 7 data under each. So I have 2 data sets, group A and group B. And in each, I have 7 data, right? So here are the some of the calculations. You can calculate mean, you can calculate median, mode, range, variance, standard deviation, standard error, and then 95% confidence interval. Everything can be calculated. And here, if you see, I have given the formula that is associated with. So in this formula, you cannot change even a minute thing. So I'll tell you here, this formula is representing only this particular column. I will do it and show you. That time you will have better understanding of that. Okay, right. So this is all about the descriptive statistics. And this is for correlation coefficient. How will you do with Excel? So I want to know whether there is any correlation between diameter and thickness. So this can be done with Pearson's as well as Spearman's. Spearman's is opted only when you have non-parametric data. Non-parametric data means what? If you have fluctuations in your data, you will call them as non-parametric, not equally distributed. Here, this is only a parametric data, whatever I have taken here, But still, I have applied a Spearman's correlation coefficient just to show you how it will look like. So these are the 6 tablets. For 6 tablets, the diameter is given and thickness is given. Forget about the units. We don't bother about the units now. We have to find out whether there is any correlation between the diameter and thickness. Is there any correlation? Yes. If it has correlation, your R value, R is the representation for correlation. So your R value will tell you whether it is having correlation or not. R can be from -1 to +1. -1 means it has negative correlation. The more the value towards -1, we can say that it is more negatively correlated. The more towards positive +1, we can say that it is positively correlated. So for same data, I have assigned the ranks. In Pearson's correlation, you do the correlation using the data as such. Whereas in Spearman's correlation, we assign rank. Rank can be assigned either from lowest to highest or from highest to lowest. Anything, whatever you do is correct, but whatever you follow the same thing for both the data set. So this is the rank for the diameter and this is the rank for the thickness. And we calculate using the correlation, same formula, but for rank, not for the data. This is the only difference, right? So when you do in that way, you can see the difference. See, there is a lot of difference in the data. So that is why this is preferred only when you have non-parametric data set, not with parametric data set, right? So when you have a non-parametric data set, you can prefer doing Spearman's correlation coefficient. So these are all, your correlation coefficient is part of inferential statistics. So this is again an interesting thing, regression equation, which is again, you can find out y is equal to mx plus c. And here I have taken an example of the cell count and the absorbance, the respective absorbance. You can plot the graph, you can add a trend line, you can find out whether it is having any relationship or not. Here also you can calculate R square value, and then this is the regression equation that is given by Excel that you can formulate easily. Just within 2 minutes you can formulate easily. But if I show you the formula for calculating regression equation, you will definitely faint, right? So, okay, so next one is t-test. So in t-test, we have unpaired and paired t-test. So here is one example for unpaired t-test, where the yield of potatoes in kgs are measured by in different plots by using fertilizer A and fertilizer B. So now what kind of thing you will try to find out? Which one is better? Whether A and B are significantly different. Again, we are not bothered about here which is A, which is B. That is your part of study. You know what is A, what is B, right? So how will we carry out this particular study is the steps, what I have said earlier. You remember, first step will be setting up of the hypothesis. So how will I go about the hypothesis? My hypothesis will be A is equal to B. The yield of potatoes using fertilizer A is same as that of fertilizer B. That will be the null hypothesis that I will assume before I do the calculations. That will be the thing that I will assume. So after null hypothesis, I will fix up 0.05 as level of significance. Then with Excel, with the help of Excel, I can calculate the t-test. So whatever value you get here, this is the formula what we use for calculating the t-test. That is shown at the bottom. Okay, this is the value what you get for t-test. So when I do the t-test and get the answer, this is said to be the p-value. If p-value is less than 0.05, I have to reject the hypothesis. Reject the null hypothesis. It means that there is a significant difference between A and B. If it is greater than 0.05, I have to reject the null hypothesis, right? So same way, this is called as paired t-test. Why it is paired? Because we are taking only 8 subjects for study, but we are doing the measurement of pulse rate before eating and after eating. So same set of subjects. So this is said to be paired t-test. So this is the formula we use for paired t-test. There is a slight difference. You can see here 2, 2, here it is 2, 1. This is the major difference. Okay, so the result is given here. So if the whatever result you are getting, this is said to be the p-value for t-test. So if the p-value is lesser than 0.05, it means that there is a significant difference. You have to reject the hypothesis. So in this case, what will be my hypothesis? What will be my null hypothesis? The pulse rate for the subjects before eating and after eating are same. There is no significant difference. There is no impact of eating. Is there any impact? Does the pulse rate change because of eating? That is our question. So we assume something before we do the thing and we give an inference. We give some inference out of this study. That is why it is called as inferential statistics. And next one important thing is ANOVA. I am not going to take you with the one way, two way, because all this requires much time. You need to attend 1 week of workshop, only then you can be familiar with all these tools. Okay, it is not possible to introduce everything within 1 hour. I am just trying to squeeze everything so that I want you to at least know what is what, right? So ANOVA is analysis of variance. If you want to compare more than 2 sets, then you have to take up ANOVA. And here it is ANOVA one way. One way means you are comparing only one variable. So variety 1, variety 2, and variety 3, but you are comparing only one variable. Maybe I can say yield of first variety, second variety, and third variety. Or it can be the length of something, length of the grains, length of wings, or length of something else. So length of the root, what you get. So it can be anything, right? So you are comparing only one parameter. So this is said to be ANOVA, and this entire ANOVA can be done with using Excel. You don't require any other. I've seen some of them use online software tools. No, not necessary. Don't rely on all those. You can use your own Excel spreadsheet for doing one-way, two-way ANOVA very easily. And here is the ANOVA table. You can quickly copy and paste it in your presentation slides and in your thesis. It gives you the entire ANOVA table itself, the source of variation. That is, in ANOVA, you will compare between the groups. What is the variation that is happening between the groups and within the groups? Between the groups is what we are interested to find out, and within the groups is nothing but the error, what you executed during your experimental conditions. And these are the degrees of freedom. Of course, I can teach you with formula also. Without using Excel also, you can do it with paper and pen using formula. That is also possible. But here, the main concept is to introduce you with the Excel. So this is the F value, what we calculate. So you can see here, the P value is given, and this is said to be the F critical. F critical is nothing but the table value. So this is how the table will look like, right? So when you do ANOVA, you can simply find out just by using this p-value. Always remember, p-value lesser than 0.05, there is significant difference. Reject the null hypothesis. If p-value is greater than 0.5, no significant difference. Accept the null hypothesis. This should be your mantra for inferential statistics. Other way is to compare F is, this is the calculated value, this is the table value. Actually, when you do it with Excel, it will give you the table value also. But sometimes, if you do it with a calculator, you have to pick up the table value using this table. So here I will go with the degrees of freedom 2, 12, which is almost 3.89, which merges with 3.89. And you can see here the level of significance of this table is 0.05. Right? So I compare this F is calculated value. This F critical is the table value. Right? So F calculated is, if it is lesser than the table value, you will accept the hypothesis. Accept which hypothesis? Null hypothesis. If it is greater than the table value, you have to reject the hypothesis. So it means that here we have to reject the null hypothesis. That means there is a significant difference. Right? So these are the different ways of doing it. And now I'll quickly switch over to, I'll stop this sharing and then I'll switch over to the Excel. So in Excel, these are the descriptive. Can you able to see this?
Yes, ma'am.
Yes, right. This is the Excel spreadsheet. Hope you all would have done some part of work. So same thing, this is how I have done, and I have copied this in your PowerPoint so that in future also you can have a look at it. Okay. So even if you want, I can share this Excel sheet also with the organizer. You can get it through mail and you can go through it. So this is what is given here. We can calculate the mean, median, mode, everything. So I'll quickly do this here. So I have introduced you with the formula. Actually, we are running out of time. So at least a few calculations we can do. So here, wherever you want the calculation to be done, you place the cursor. You can, one way of moving on to the formula is go to formulas and then insert function, or you simply press equal to sign. Automatically it will ask you for the formula. So you can type average. Average means nothing but the average. So we can quickly pick that, and you have to select from which number to which number. So you can see here I am just selecting them, dragging and dropping, right? So with this you can calculate the mean value. So same thing should be done for group B, but it is not necessary to do it again. It is not necessary to introduce the formula again. What you can do is place your cursor here. You can see the plus sign there. Simply drag and drop to the next column. Automatically the formula will be copied. So you can place the cursor here and you can see here how it is being calculated. See, if I place the cursor here, it says here it is 13.2. It's just a number. Whereas if I place the cursor here, you can see it is the value that is entered because of the average of B2 to B7. Same way, if I place the cursor here, it is the average of C2 to C7 over. So if you have some 10 sets of data, you can simply just drag and drop up to this. Just drag and drop, the formula will be calculated over. Right? So that is the beauty of Excel. And okay, one day you have done this, next day you want to change the value. You simply change the value alone. Automatically, the entire thing will change. It is same for everything. So now let me calculate median. Median is called as median. So once you type, it will automatically ask for you. So you can see there, it returns the median or the number in the middle of the data. So it will show you everything, self-descriptive. So you have to select here again number. Be careful in selecting only those numbers for which you need to calculate the median. Right? Same way, drag and drop over. So next is mode, equal to mode. So you can see here, mode is the function. You can select here the numbers. Right? So it is not applicable because there is no mode. Say for example, I am changing this value to 14.3. Now it's entering at us 14.3. Right? So similarly, you have a formula for range. For range, it is maximum minus minimum. So you can select maximum and then select the numbers, right? And close the bracket, put a minus sign there, and then go to minimum, type minimum. So it is showing this, select this, then You have to really do it and check it. Only then you will understand. Then select this, close the bracket so that you will get the range. That's all. So again, I can drag and drop this to the next cell so that it will give you the entire detail. Right? So you can see the formula here. So how it is being calculated for standard error, you don't have direct formula for standard error. So you have to first calculate standard deviation and then the square root of count that particular thing. Count is nothing but number of data, what it has. So all this you can do it and it will give you the value, right? And next important thing is the correlation. So another one interesting thing here is, so this is one way of doing, using the inbuilt formula, whatever is there. Another easiest way of doing descriptive statistics is, you select the entire data for which you need descriptive statistics to be calculated and go to data. You can see different tabs here, right? So people are keep on joining. It's highly disturbing. So you can see the different tabs here. You select the data tab and go to data analysis tool pack. If you don't have it in Excel, you should install this as an add-in. Okay, as an add-in. So go to data analysis and then select the descriptive statistics from this and give OK. So it will ask you what is the range for which it has to be calculated. So give this as the input range. And then you can retain the labels and you can select the output range. It can be in new worksheet also. It can be in new worksheet. Select the confidence level, that is 95%. 95% is nothing but this. That is 0.05. And give OK so that a new sheet is opened. A new sheet is opened. And it gives you the entire value. Data analysis, descriptive statistics. Yes, I need summary of statistics. If I give that, you can see here the entire thing is ready now. So for group A, what is the mean, standard error, median, mode, everything. Skewness, everything is given at one go. Confidence level, everything. How many count, how many number of data you have, what is the sum, what is maximum, what is minimum, what is the range, everything. You need not even have to use the formula, whatever is there in the other tools, right? And next one is the correlation. So this is what we have seen in correlation. So I have taken same thing here. You just introduce the formula equal to will always give you a way to introduce a formula and type a CORREL. So it is coming and you have to select array 1 is this, comma, array 2. Array 2 is this, right? And select enter, you will get the answer. So here, this is Pearson's, this is Spearman's. The only difference is we are taking the data as such here. Here we are taking the correlation. We are calculating correlation for the rank. So equal to CORREL. Select the array 1, comma, then array 2. Enter, you get the value. Right? So next is regression. So this is what is being done using this. So this can be done by, I'm deleting this. So now what I do is, this is the data set what we have. Select the entire thing. Go to insert. Select the scatter plot. Right? I am deleting all this minor grid lines and then this. So now you are not supposed to select the line graph. You have to select a scatter plot. Then select all the points, right click, add a trend line. So you can ask it to set for intercept, display equation and display R square value. Select all this and now my trend line option is in linear. So trend line option should be in linear. That is most important because we are calculating here linear regression coefficient, right? So then git closed, so you get the entire thing. I'm deleting this because that's not the title here. So here you can get the R square value. R square is 0.9031. You need not even have to calculate correlation coefficient using the formula. It automatically gives in your, so your graph, your formula, everything is ready. Just by one click, entire thing is ready now. So this is the regression equation. So you can substitute X value and you can calculate the Y value. So these are the cell counts. This is the absorbance. So if my cell count is somewhere around 5.6, what will be the absorbance? I can calculate using the regression equation here, right? So everyone, those who are into research must understand. Okay, so this is for t-test. This is the table, how to calculate t-test is shown here. So I'll simply delete this and I will go with the formula equal to type t-test, right? So the moment you type that, it asks, it guides you. What is array 1? What is array 2? So array 1 is this. So see, that is being highlighted. So put a comma so that, see, the highlight is just moving. It's navigating to array 2. So now select array 2. It means that you have already navigated to the next thing. So select array 2, then comma. So tails. So it is asking whether you want to calculate one tail distribution or two tail distribution. So one tail is nothing but if you say she is girls are taller than boys, that is said to be one tail distribution. Or if you assume that boys are taller than girls, if your hypothesis is like that, if you go with the alternate hypothesis, then that is said to be one tail distribution. If you have null hypothesis, both are of equal heights, both girls and boys in my class are of equal heights, there is no difference between their heights, then that is said to be two tail distribution. So you have to type 1 if you are going with one tail distribution, or you have to type 2 with the two tail distribution. So I am typing here 2, and the next is 1, 2 and 3. You have 3 options here. One is for paired, another is for 2 sample equal variance, another is for 2 sample unequal variance. So here we can type 2 sample equal variance. Actually, we are not calculated any variance here. So if you calculate the variance, you will know whether it has equal variance or unequal variance, or randomly we can give as 2, but you should not give 1 because it is not paired. Only your next data set is paired. So I'm closing the bracket and select enter, right, over. So here, what is the difference? Same thing is applied here. Array 1, array 2, then 2 is the one tail or two tailed test. Here 1 is for paired sample test. Why paired? Because same sample. My subject is same sample set. Here the plots are different. You cannot use you can use fertilizer A and fertilizer B. Either it should be in different plot or one after the other. So this is different. Whereas here you are using same subject, but you are finding whether they are having difference between pulse rate that is measured before eating and after eating. Right? Is that clear? Next, last one is ANOVA. So this is what we get here. So I'll just simply copy this data in another Excel sheet and then do it ANOVA for you. So I have copied and pasted here, right? Same thing. So what you do is it's very, very simple. Select the entire data. Again, go to data here. Where is it? Data, right? And go to data analysis toolpath. So you can see here ANOVA single factor, ANOVA two factor with replication, ANOVA two factor without replication. Ours is single factor because it is one way ANOVA. Select OK. So it will ask you for input range. Input range is this, right? And you want to retain the label in the first row. Alpha value is 0.05. So you can give the output range. If you want the output, that is your final data to be in same sheet, you can select the output range, or it can be in the new worksheet also. So I give OK. So what happens? See, it has immediate, the very next moment, It gives you the entire thing. The very next moment, it shows you the entire thing. So that too in news sheet. So you have to just copy the entire thing in and paste it in your thesis or presentation or in your article, whatever it may be. So it gives you the ANOVA table. You can see this kind of ANOVA table everywhere. And finally, they will give an inference. So your test, whatever you do, whether it is t-test, whether it is ANOVA, whether it is correlation, all this should have what? Inference. That's why it is said to be inferential statistics. So what will be my inference? You can give the inference two ways. One is by checking with the p-value. If my p-value is lesser than 0.05, I have to reject the null hypothesis and accept that there is a statistical significant difference between the data sets. When will you do ANOVA? Only when you have more than two groups of data set, right? And or other way of comparison is you can compare F table value, sorry, this is F calculated value and F table value. Compare these two values. Compare these two values. So when you compare these two values, if this is greater than, if calculated is greater than critical, you have to reject the null hypothesis. It means that it has statistical difference is there between the three varieties. But which variety is better, that you cannot say now. You can only say they are whether they are different or not, or same. Only that you can say at this point of time. You have to do further more statistical analysis in order to exactly find out which is having more value in your research. That you have to dig in further, right? So that's all from my end. Hope it would have been useful for everyone. And I thank Aditya Institute for giving me this opportunity. Thanks for the organizers. Thanks for Bharati Madam and Sucharita Madam for giving me an opportunity to meet all enabled person, all research person in our pharma field. Thank you, Madam. Any questions or doubts?
Shall we take some questions,
Yes,
ma'am?
sure.
If you have any questions, you can post it in the chat box so that I can read it for ma'am and she can answer you the questions.
One final suggestion, don't be afraid of statistics. Please take it up because world is moving towards data science and artificial intelligence. Statistics is a stepping point. It's a stepping point. You will find the data science and artificial intelligence very interesting only when you understand the statistics. Don't be afraid of, take it as a challenge. Please do it. At least please try some of the tools in your own research. Nothing wrong in checking in your, maybe you're not going to do any consultancy work for our industries, right? So at least for your research, please use Excel. You can use Excel. Don't be running behind software. Don't give excuses. Don't go for a SPSS software. Not necessary at all. Okay. You can very well use Excel.
Okay.
If you leave me, I'll be talking 2 days also. So
well, we have a lot many messages in the chat box, pouring messages saying that the wonderful session and very informative.
thank you.
So yes, so I think we didn't get any questions.
No questions then.
Yeah.
I didn't understand anything.
No, the moment when I heard about this webinar, so I was thinking like, so it is going to be very complicated because statistical methods, whenever we hear this term, it is like a nightmare, you said, okay. So, but you made it very simplified, which is like the first session, which made me very clear about the statistical methods, because most of the time we in the research, what we do is without knowing any statistical methods, we simply say ANOVA, we simply say students test, but we don't know what it is exactly. But with your beautiful presentation, I think you have clearly explained what it is. And I really understood about how, how to pick up the statistical method. Ma'am, we have some questions here from someone. Is it necessary to apply ANOVA to in vitro activity?
No, it's up to you. See, if you want to compare three different data sets, see, ANOVA, that's what you are, instead of saying, yes, there is some difference I find it better, instead of saying some statement uh, without any evidence. This, you can say your statement, you can uh, prove it with evidence, right? If you can use all the statistical tools and you can say with evidence. Your inference can be with evidence. It adds evidence for your significance for your results as well. So it's up to you. And there is no hard and fast rule. You have to use ANOVA or you have to report it with. But nowadays, it has so become. It's so important that you have to include all these tools. That's what a research demands, is it not?
Yes. Ma'am, there is one more question. Is it possible to do two-way ANOVA?
Yes, yes, yes. You can do two-way ANOVA. You can, in fact, do two-way ANOVA with replication and without replication using Excel spreadsheet. Definitely, you can.
Okay. Someone asked, can you have any drug release chart explanation? I don't know what it is exactly.
No, that's what we have, different drug release kinetics, right?
Yes.
Probably madam would have been involved in pharmaceutics research. So I think again that will take a lot of our time. So maybe next session or next other presentations we can even talk about that. That's what, it's a very vast area, very, very tough. I found it very difficult to concise into 1 hour. Of course, I have taken 1.5 hours, I think. It's very tough to concise. In fact, I have skipped some of the calculations using Excel, like a chi-square test. I have not touched F-test. I have not touched ANOVA two-way. So it requires 2 or 3 days workshop. Only then we can talk about each and everything.
Yes. So that's all, ma'am. Only these questions we have.
Okay.
Thank you very much, ma'am, for your spending your
Thank you.
time and making us understand about the statistical methods in pharmaceutical research. And definitely, we are looking forward to hear more from you, more sessions from you. Thank you very much, ma'am.
Thank you, ma'am. I was looking for this opportunity because I am not basically a statistician, because my M.Pharm is in pharmaceutical chemistry and my PhD is in analysis. So I learned all this on my own. So I want to share to others. So thanks for this wonderful opportunity. I will not
But it is quite
forget in my lifetime.
But it's quite surprising, ma'am, to hear from you, in a very, what to say, you have very much knowledge on the statistical methods. It's quite surprising because that's what I was thinking when I saw that, I was thinking that you would have done something in statistics and computer science. But when I saw your profile, it was quite surprising that you're
No.
from
I
pharmacy.
learned everything on my own. Still, I am learning to use R software in statistics. So probably in next year, I will be in a position to teach you statistics using R software also.
Okay. Okay, ma'am. Thank you so much, ma'am.
Thank you,
The feedback link has been already given in the chat box, so you can fill the feedback form. And I would like to thank our chairman, Dr. B. A. Vishwanath, for organizing such webinars and for continuously motivating the staff and encouraging us to conduct the webinars. I also thank our webinar convener, Suchitra ma'am. Thank you, ma'am. Thank you very much. I also thank all the participants for your cooperation during the session. Yes, ma'am.
Thank you, ma'am.
Thank you, ma'am. Yes. You can
Yes, ma'am.
disconnect, ma'am.
Yes,
So
ma'am.
I'll just wait for
Thank
2
you.
more minutes so that, if they have
Okay.
anything on the
Okay.
feedback. Thank you so
Yes,
much.
yes,
Yes.
definitely. I'll share you the PowerPoint as well as Excel. You
Yes,
can
ma'am.
share to
Yes,
the
I will share with everyone.
Yes, you can please send your mail ID, or shall I send it to Suchitra madam?
I'll text you, ma'am. My email ID, I'll text it to you.
Okay, ma'am.
Okay, ma'am?
Yes, ma'am. Yes,
Okay.
ma'am.
Thank you, ma'am. Thank you so much.
Yes, ma'am.
So I hope you have received your feedback link. Can anyone respond?
Yes, ma'am.
Yes?
Yes, ma'am.
Okay.
Yes, ma'am. Yes, ma'am. We received it.
Okay, fine. Thank you. Then I'll end the meeting. Or you want me to wait for a minute? Okay, I'll wait for a minute. So
Yes.
that Yes, if you have any doubts regarding the
Yeah,
feedback.
ma'am, you can.
Yeah,
No, we can end the meeting, ma'am.
sure, sure. Thank you.
Thank,
Thanks for your
thank you, ma'am.
participation.
Yeah.